Now, before I start example 2, I'm going to make a folder, call this example 1. I didn't need to do that. And we're going to put these in that folder and collapse that. So now we have example 2. An object is 4,900 feet above the ground. The object falls and its height is given by the quadratic function h of t equals negative 16t squared plus 4,900. The height of the object above the ground is in feet and the time t is in seconds. What is the object's initial velocity? So we need to understand that when an object is falling, that means it is starting at rest. It is not moving at the beginning when t equals 0. So when an object falls, v sub 0, our initial velocity, is 0 feet per second. The object's height after 10 seconds, f of 10, can be found by plugging in negative 16 10 times 10 squared plus 4,900. So when we do that, negative 16 and 10 squared is 4,900. So for this problem, we get 3,000 300 feet. Always remember the units. How long is the object in the air? That means we want to know when does it hit the ground. So now we need to go here and type in the equation y equals negative 16x squared plus 4,900. And here we just need to slide along the x-axis to find that positive 0, and we see it is 17 and a half. X equals 17 and a half seconds. Example 3, a model rocket is launched from the top of a cliff that is 384 feet high with an upward velocity of 160 feet per second. So if I'm given this information, I should be able to model my equation. Y equals, and here this is in feet, so I'm going to have negative 16 t squared, and we can use t or x, plus initial velocity 160 t plus 384 is my initial height. So here we can collapse example 2 down to example 3. We have y equals negative 16. And it doesn't mind t too much from what I can remember. Squared plus 160 plus 384. So we want to know how many seconds after the launch does the rocket reach its maximum height. So again, we can try and use the graph to find this. So if I zoom out far enough, and then if I zoom in at my solution, my vertex rather, I can click on my vertex and it tells me that the x value is 5. So maximum height, this is asking for the x value of the vertex. And the other way that we can find this is using axis of symmetry. So if I know x equals opposite of b over 2a, if I had negative 160 divided by negative 32, I thought that was in Desmond's. You get 5. We don't always have to use the graph. I don't want us to become too dependent on the graph. So if I want to determine the maximum height attained by the rocket, our vertex tells us that it is 784 feet. I could also find f of 5. So if I replace t with 5 in my equation, I'll get the same thing. How many seconds after the launch does the rocket reach the ground? So now for this, I can go back to my home view, and we want the positive 0. So we see there that x, and here I forgot my units. Here x is seconds, y is feet. After how many seconds? 12. So now here we get into some other types of word problems. So if we're finding two integers whose sum is negative 15, so if I'm going to name these two integers, we'll just call them x and y, and their product is negative 54. Looking at this, I don't have a quadratic equation, but I know that if I have x times y, if I can write this in terms of just x or just y, when I multiply those by each other, then I could get a quadratic. So I'm going to solve for y by subtracting x. And then I'm going to replace this value here for y. So y is negative x minus 15. And now I have a quadratic. Negative x squared minus 15x. And this is negative 54 equals negative 54. Now, in order for me to put this into Desmos, I need to get all of my terms on one side. So I'm going to add 54. So y is going to equal negative x squared minus 15x plus 54. So y equals negative x squared minus 15x plus 54. And here, because I have a negative product and a negative sum, I should expect a positive answer and a negative answer. So here we see x is going to equal negative 18 and positive 3. And we see that negative 18 plus 3 is negative 15. And in Desmos, negative 18 times 3 is negative 54. For example, 5, when we get into consecutive integers, consecutive just means in order. So I'm going to have x and times x plus 1. So I have consecutive integers. And this was a typo. Let's make this 210. So going to equal 210. So I get x squared plus x equals 210. Need to subtract 210. So y is going to equal x squared plus x minus 210. Squared plus x minus 210. And if we look at these numbers, we see we get 15 and 14. But here's the thing, it has negative 15 and positive 14, but I want consecutive integers. So I need to realize that these are going to be x equals 15 and 14, or x equals negative 15 and negative 14, because both of those have a product of 210. So we have a positive set of answers and a negative set of answers. Example 6, the length of a rectangle is 4 centimeters more than the width, so it's the width plus 4, and the area is 96. We're going to find the dimensions of the rectangle. So we know that area is length times width, and that equals 96. So I'm given my length in terms of width, so I can say that my width times my length, which is W plus 4, is going to equal 96. Let's move this up. So then I get W squared plus 4W minus 96 equal to 0, because I distributed and then I subtracted 96. Make sure that we are not putting equals 0 into Desmos. Desmos does not like when you set stuff equal to 0. It's not going to give you a parabola if you set it equal to 0. So this is what we need to enter into Desmos. So then we have example 6. Y equals W squared plus 4W minus 96. So understand that I cannot have negative width. I cannot have a width that is negative 12 inches. So that means that if W equals 8 and L equals W plus 4, then L equals 12. So I'm going to create a second video for examples 7, 8, and 9 because they are a little bit more complex.